Hello guys, this is Paul McWhorter with TopTechBoy.com, and we're here today with episode number 17 in our incredible new tutorial series where you're teaching your Raspberry Pi who's boss. What I'm going to need you to do is pour yourself a nice tall glass of ice cold coffee. That is straight up black coffee poured over ice, no sugar, no sweeteners, none needed. And as you're pouring your coffee, as always, I want to give a shout out to our friends over at Sunfounder. Sunfounder is actually sponsoring this series of video lessons, and in this class we will be using the most excellent Sunfounder Ultimate Raspberry Pi Kit. Now, I am really hoping that most of you guys already have your gear, but if you don't, look down in the description. There is a link over to Amazon. You can hop on over there and get your Sunfounder kit. Now, believe me, your life and my life are going to be a lot easier in this class if we are both working on identical hardware. So if you don't have your kit yet, hop on over there and order one. But enough of this shameless advertising. Let's talk about what I am going to teach you today. And what I'm going to show you is I'm going to show you my solution to the homework assignment that I gave you in episode number 16. Now remember, in episode number 16, we had created a dimmable LED by making analog reads through the most excellent ADC 0834 analog to digital converter chip, and then to take that data and create a pulse width modulation signal where we could control the brightness or dimness of a red LED based on the position of a potentiometer. Now, what your homework assignment for today was to, instead of using the red LED, use the RGB, the red, green, blue LED, and hook it up and have 3 potentiometers, and then be able to mix any color in the rainbow by adjusting the relative brightness of red and green and blue with the 3 potentiometers. First of all, how many of you guys were successful? If you were successful, leave a comment down below. I am legend. And if you were not successful, leave a comment down below. I folded up like a cheap Walmart lawn chair. Okay. Now I'm hoping that most of you guys were able to figure this out because it was just applying a pretty straightforward application of what we learned in lesson number 16. But instead of just doing it for one potentiometer going to one LED, we have 3 potentiometers, and it's connecting to 3 legs of the RGB LED. But there's nothing that you have to think a whole lot about. You just got to set your channels up. Now, where I think this probably was a little bit challenging, this is getting to be a more complex build. And so you have to be a lot more careful as you're putting this circuit together, and more coding. So it's just kind of like a little bit harder version of things that we have learned before. But enough of this banter, introductory banter and chit chat. Let's jump in and let's see if we can get this thing built. Let me start by showing you my schematic and my build, and I'll do that here, and I will get out of your way. Now, I'm not going to build this thing. I'm not going to build this thing wire by wire and component by component, because you should pretty much kind of understand this. And I'll make a couple of observations. The first is, you can see that since we're using this analog to digital chip, and we're using 3 potentiometers, and we're using an RGB LED, this build is starting to get pretty complicated. So you really need to go to these jumper wires. If you don't have them already, look down in the description, link over to this set of straight wires. And I just really think by the time you get to this point, it's going to be hard to use those loopy wires. You really need a nice straight wires and a clean build here. The other thing is, you got to really kind of think about what what you're doing. Now you can see up top here, I show you my schematic. Up top, I show you my schematic. But the issue is that yes, you want to kind of follow my schematic up top, but you don't want to just blindly follow it. You need to understand what we are doing. And what we are doing is, before we had only been reading from channel 0, which is pin 1, 2, 3, pin 3 on the ADC 0834, but now we're reading from 3 channels. So we're reading channel 0, channel 1, and channel 2, and that corresponds to pin number 2 and pin number, or that corresponds to pin number 3 and pin number 4 and pin number 5. So we're reading from channels 0, 1, and 2, and those are pins 3, 4, and 5. And I always like to do things in the same order, and so that's RGB. Channel 0, pin 3 goes to the red channel. Channel 1, pin 4 goes to the green channel, and then channel 2, which is pin 5, goes to the blue. So this is RGB. This is RGB. This is RGB. I always try to kind of go in the same order because that makes it easier to keep things straight. So down here, what we're doing is, on the potentiometer side, each one of the potentiometers, the outside leg needs to go to the positive rail, the other outside rail needs to go to ground, and then you need to connect the center pin up to either channel 0, 1, or 2. Okay, and then that all becomes fairly straightforward after that. And then the chip itself, we already hooked up, so I won't talk a lot about that. Go back to one of the earlier lessons if you want more information on that. Now here is the RGB LED. Each leg of the RGB LED, each of the control legs, the R, the G, and the B, each need a 330 ohm resistor. And so we have a 330 ohm resistor in series with each leg of the RGB LED. And then we bring those back to GPIO control pins. And what I'm using is the red channel goes to the GPIO 23, and that's using the BCM numbering system. The green channel goes to the GPIO pin 24 in the BCM numbering system, and then the blue channel goes to pin 21. So I've got GPIO pins 23, 24, and 21 for the control legs of the LED RGB. Now what I can do is, as I turn this potentiometer, I can turn up and down the PWM strength of the red leg of the LED, and then this one will end up controlling the G leg of the LED, and then this one will end up controlling the blue leg of the LED, if that makes sense. I hope it does. Okay, also notice that I'm jumpering my positive rail from the top row down to the second to the bottom row, and then I am jumpering my ground rail from the second row down to the bottom row. So I've got 2 ground rails and I've got 2 power rails, and that should make things pretty straightforward. I think we are ready to jump in here and code this thing. And so the first thing we need to do is, rather than starting from scratch, I think it would be easier if we started from, where we left off last week, and that was where we were controlling the red LED, because if we take that as a starting point, then we've got to just kind of replicate that for the green channel and the blue channel, and that's probably the easiest way to do it. So I will need you to go to the most excellent www.toptechboy.com, and then what I'm going to need you to do is use the happy little search bar here and search on something like create a dimmable LED with a potentiometer on the Raspberry Pi. Search on something like that, you'll come to this lesson. You also see that I've got the schematic for last week's circuit. What we've done is we've added 2 more potentiometers, and we've replaced this with an RGB LED and headed to add 2 more resistors. So let's come down here and let's grab this code. Single click on the little double page icon. It says copied to clipboard. Now what we're going to do is, we are working on Thonny IDE for the last couple of lessons, so we'll come down here to Thonny and we'll open that up, and let's go ahead and save this with a program name as we're starting. And remember, I am working in my Python folder. Okay, and I am going to call this RGB mix.py, and the .py is kind of important, and boom, fresh new program just waiting for you to write it. But what we're going to do is we're going to start with that program that we ended up with in lesson number 16, and that'll help us do this a little bit quicker. And so as we start out here, we're just importing our GPIO control library, importing the ADC 0834 control library. Remember, you guys have to install this library. If you haven't already, if you're just jumping into this lesson, go back to the last lesson or the lesson before the last lesson. That would be lesson 15. And make sure that you get this library installed, because this program won't work without the library. And then we are going to import time. And I think that I am going to, I did not do a really good there. I'm going to say from time import sleep like that, so I don't have to just keep typing time dot this and time dot that. And then I'll come down here, and then this should be just a sleep point too. All right, like that. That just cleans up a little something I should have done better. All right, now we are going to be using the BCM numbering system on the Raspberry Pi. Why the BCM numbering system? Because the SunFounder breakout board here, this T connector, it has the pins labeled, but it labels them in the BCM numbering system. And our life is going to be easier if we are coding using the same numbering scheme as the labels next to the pins that we are using, if that makes sense. So what we've done is we've set up a GPIO set mode of using the BCM numbering scheme. Now you can see that we are using we were using GPIO pin 23. This is GPIO pin 23. We were using this one to control the red LED, but now we're going to have a red, a green, and a blue. So instead of calling it the LED pin, what I'm going to call it now is I'm going to call it LED red, because I do in fact have GPIO pin 23 connected to GPIO pin 23, which is yeah, it's this one right here, GPIO pin 23. I have that connected up to the red leg of the RGB LED. And so that would be then red LED red. And I think it's going to be easier if I just probably type these. And now I'm going to have LED green, and that is going to go, I said it a while ago, that's going to go to GPIO pin 24, and then the LED blue is going to be going to GPIO pin 21, and that's the one down here. That's the one down here in the corner, GPIO pin 21. So I think we've got those things hooked up pretty well. I think that gets us started. Now here where we did the GPIO setup in the earlier program, instead of LED pin, we're going to call that what? LED red. And then if we're going to do LED red as a setup, we're also going to need to do what? We're going to need to do those other two. So I'm going to Control C to copy, come down here, paste, and then come down here, paste. I'm Control V-ing to paste. Hopefully that makes sense. And then here where we have LED red, we're going to now have LED green, and then we are going to have LED blue. Now, do you guys see how I'm doing this the same every time? Red, green, blue, red, green, blue. Makes it a lot easier if you're a little bit mindful and deliberate in how you name things and how you do things, and particularly if you spell blue correctly, B-L-U-E. That looks good. Okay, so I've done my GPIO setups. Here I started my PWM is GPIO.pwm. Well, now I'm going to have three, so I better, instead of calling this my PWM, I'm going to call it my PWM red. Okay, and then that is LED red, like that. Now we're going to need to do that how many more times? We're going to need to do that 2 more times for the other channel. So Control C, enter, Control V, and then here what we are going to do is, instead of my PWM red, this is going to be my PWM green, and then this is going to be LED what? Green. And then we're going to come down here, my PWM blue is going to come over here to LED blue. Okay, so now I've got the PWM set up on my 3 channels of the RGB LED. And here, what did I do? I started my PWM, but I don't have my PWM anymore. Now I have my PWM red. The red channel is started at this point, but what am I going to need to do? I'm going to need to start those other 2. And notice I started with a duty cycle of 0. I started with a duty cycle of 0, meaning they're going to start off. Now also notice up here, I like to use a frequency for the PWM of 1,000. And so you can see I set those things up as 1,000 to get us started. But now I will need to Control V, and now this one was start the red channel. Now I'm going to start the green channel, and now I'm going to start the blue channel. Okay, so we've got everything set up. The next line of code kicks off that ADC 0834 chip. This will turn it on by calling the library and getting it all initialized. Then what do I do in the while loop down here? I'm just reading the analog value from the ADC 0834, and I'm getting the result from where? From channel 0. From channel 0. Well, what I'm going to need to do is I'm going to need a better variable name, because I'm not going to just be reading from channel 0. I'm going to be reading from channel 0, channel 1, channel 2. I'll need 3 variables, and I'm going to name the variables according to their color. And so this first one was what? It was the, let's see here, let me do just a tad bit of getting things where I can see them better. Okay, so this is going to be, instead of analog value, let's call it analog what? Analog red. Okay, and now we need to do that. How many more times? We need to do that 2 more times. So I will Control C. I will come here, Control V. And that did not paste very conveniently, so get rid of those extra tabs. And here, this is analog what? Analog green. And that's going to be read from which channel? From channel 1. Okay. And now I'm going to have analog blue. Analog blue is equal to ADC 0834.get result. And then what channel am I going to read from here? Channel 2. Okay, so now I have 3 values. The values that I am getting from the left potentiometer is analog red, because that is connected to channel 0, which is pin 3. And then this potentiometer, the middle one, is reading from is going to be our green potentiometer, or controlling the green channel, and it is going to channel 1, which is pin 4, and then this one is going to be our blue channel, and it's going to go to pin 5, which is channel 2 over here. So now we've got those 3 values. What do we need to do? Let's see, I think I'm going to go ahead and print those, and so I'm going to modify this print statement to sort of give me, this would be raw red, and that's going to be, instead of analog value, that's going to be analog red. And then the voltage that is being applied is, now I'm not going to do this. You know what I'm going to do? I'm going to add the other ones all in a row instead of doing both of them, because I don't think we need to convert that anymore. So I'm going to say raw red is analog red, and then comma, and then I'm going to print the label raw green. Remember, it's always red, green, blue in that order. That makes it easier. And then what? Analog green, like that. And then comma. And then what? Raw blue. Okay. And then that raw blue equal, like that. And then what is that going to be? That is going to be analog blue. We're going to print like that. Okay, now I think by doing that, I should have one line that gives me the red value, the green value, and the blue value. And I'm going to turn all of these down to begin with, so they should be off. Okay, they should be off when this thing starts. And then did we set them up here? Yeah, we set them all for a duty cycle of 0, so they should all start out with themselves being off. Now, I calculate the duty cycle because this ADC 0834 is going to read between 0 and 255. But pulse width modulation wants a number between 0 and 100. So I need to convert a number between 0 and 255 to a number between 0 and 100. We did the math last time, and using a linear equation, we saw that you multiply by 100, divide by 255. But now we're going to have 3 duty cycles, one for red, one for green, one for blue. So we're going to say this is the red, DC red. And then this is going to be, instead of analog val, that is going to be analog red, because that is what we just read in. So now we'll Control C, and now we're going to Control V and Control V. And then this was DC red. This is going to be DC green. And then that would use analog green. Okay. And then red, green. And then blue, and then this is going to be analog blue, like that, okay? And now what we're going to need to do is what we did here is we said my PWM. This is where we're applying that calculated value to change the brightness of the channel. But before we had one channel, which was my PWM, but now we have my PWM red, my PWM green, and my PWM blue. We need to apply all of those. So my PWM red is going to use what? DC, duty cycle red. And then what do I need to do? I need to do this 2 more times. Control C, Enter, Control V, and we just start getting more and more useless tabs. Okay. Okay, so now we have my red, we have my green is going to use duty cycle green, and then my PWM what blue, BLUE, is equal to DC blue, and then this is going to be 2 E's in green. And you probably didn't even see that because my head was in the way. But hiding behind my noggin was an error in the code. But it's not a mistake if you catch it before you run it. Okay. Then we just give it a sleep. We give it a little bit of a delay time here in order to not just be hammering this thing too hard. And so could it really be this easy? Analog red, analog green. Analog blue. I'm just trying to find misspellings. DC green, DC blue, DC red, blue, green, red. So you guys see how really you do it one time and really think about it. But if you name your variables right and you're methodical, then the other ones just happen really quickly because you only really had to think real hard on the first one. And so this is analog red, analog green, analog blue. That looks pretty good. I will need everyone to hold their breath. Oh, LED blue is not defined. What is this nonsense in line 13? In line 13, LED blue is not defined. I see what I did. I put an uppercase there. You might think it's my fault, but it was one of you guys didn't hold your breath. Okay, let's try it again. And this time I will need everyone to hold their breath, and we are going to try it again. Okay, now look at that. It looks like that we are reading raw red, raw green, raw blue, and we are reading 0, 3, and 0 or 2. And you can see that the LED is almost off. Be careful not to turn these too far to the left, but as I'm turning them to the left, I'm not getting absolutely perfectly reading a 0. And there's sometimes a temptation to try to just move it a little further to get that 0. And when you do that, you really risk damaging the LED. So I think instead of doing that, what I'm going to do is Control C. And I'm going to come up here. And what I'm going to do is after doing these duty cycle reads, I'm going to say if duty cycle red is less than or equal to, let's just say 3 and see if that works. Just so if it's bouncing around there at the bottom, the LED will stay off. Give it a little margin for noise there. If DC red is less than or equal to 3, then what we will say is the duty cycle red, then just make it 0 so that it's not sitting there kind of blinking. And then what we'll do is we'll come in and we'll copy this a couple of times. Do a Control C and then come here, Control V, get our tabs right. Let's do it one more time and then we'll clean it up. Control V, and our tabs are way off there. Okay, so if duty cycle red is less than 3, if duty cycle green is less than or equal to 3, then DC green, and then DC blue, and then we'll make DC blue equal to 0. All right, now let's try to run it, and hopefully this thing will kind of stay off a little bit better. Hold your breath. Okay, now look at that. So you see what we see now is the thing is actually off. Now let's see if I just bring the blue up. Okay, there the blue comes on. And then you can see that it's going brighter and brighter and brighter blue. Again, these LEDs sort of blow the camera out, but when you look at this in real life, it really looks good. And let's bring it down carefully, and we get it down to 0 or 1. And it's pretty well behaved down there. Okay, now let's go for the next one. And then we can see the green channel is coming up. Okay, and that one looks good. We're getting proper dimming of green. And then the red is coming on and coming up. That looks really good. Now, what if we do red and blue? If we do a little red and a little blue, what do we start getting? We start getting a beautiful purple. And kind of depending on how we mix, we can go from purple to pink to magenta, depending on how much we mix in. Or if we mix red and green, we will get various shades of yellow and orange. Now, if you put more red, you start going from yellow and then moving towards orange, but you can mix your yellows and oranges that way. Or if we come over and we do blue, and green, then we can get the various beautiful shades of aqua, okay? And again, you can get the various shades of aqua and turquoise. So boom, look at that. We can mix any color of the rainbow using 3 LEDs. And let's see if I bring this down, how well behaved these are. Okay. So I'm reading 1. Yeah, we probably do need to go 5. Sometimes I'm seeing a little noise up to 5 on this channel, but that's just because, you know, we don't have absolutely perfectly quiet circuits and just a little bit of noise in there. We could maybe play around with it to try to get it to read 0, but I think on something like if it's 1 or a 2, just live with it and handle it with an if statement. Okay, guys, I really hope you are having as much fun taking these lessons as I am making them. This one I don't think was really all that hard. I think the hardest thing about this one was getting your build correctly and getting your build done neatly where all of those wires were going to the right spot. And that's what we've got to get better at. Well, I'm not saying you're not good at it, but that's a skill that if we don't have, we need to develop. And that is the ability to put together a complicated board and get it all hooked up correctly. And a lot of that really comes down to being organized and sort of laying your circuit out well. And so you can see that I tried to sort of plan things like I was doing the potentiometers at the lower portion of the board. I was using the RGB LED at the top portion of the board. I was doing the LED on top and then using the GPIO pins on top. So I try to minimize the number of wires that I have cross over. I try to use the wires that are the right length where I can. Like you can see this one I didn't have to bend. This one I didn't have to bend. And then every once in a while, just to get the length right, you do have to bend a wire. But guys, lay your boards out neatly. Think through it. Don't just look at the schematic and try to copy the schematic. Think about what you're doing. Think, I'm hooking up the RGB LED. Every leg needs to go through a current limiting resistor. I am hooking up the potentiometers. The left legs all need to go to the ground rail or the power rail. The right legs all need to go to the ground rail, and the center tap's got to go to a channel. So be thinking through it. And if you think through it and don't just sit and try to blindly copy the schematic, there's a lot greater chance that you're going to get it right, because also sometimes there can be a mistake in the schematic. So be thinking through it as you are putting it together. Okay, guys, believe it or not, I don't have a homework for you, because if you think about it, this is kind of like a natural spot where we've really kind of completed a nice segment of this class. What can we do? We learned Linux. We learned the essentials of Python. We learned how to write digital signals to the GPIO pin. We learned how to simulate analog pins by writing PWM signals to the GPIO pins. We learned how to do digital reads from the GPIO pins. And now we are doing analog reads through using the ADC 0834 chip. And so sort of digital writes, analog writes, digital reads, analog reads. That is a pretty nice set of things. Now, all of that we did using the RGB LED, or we did it with potentiometers and LEDs, just because those are things that are very inexpensive components, and it's a way to kind of get started. But now what we're going to do is we're going to start digging deeper into the Sunfounder kit and start playing with some of the more exciting components in there, because you've really learned a very, very good amount of the core fundamental stuff that you need to know. And now what we'll do is we will start finding more interesting components in here to show you how to use. In all the future lessons, yes, there will be homework, and in all those homeworks, wherever I can, I want to make you solve a math problem in order to get the homework right, because there is just something really amazing where you have to do something on paper, you have to do something with math, and then you apply your sketch and you apply your math, and then you build something physically in the real world, and then you code it, and voila, all that stuff comes together to make something that is working. Okay, guys, as always, I want to give a shout out to you guys who are helping me out over at Patreon. Your support and your encouragement keeps this great free content coming. You guys that are not helping out yet, look down in the description. There is a link over to my Patreon account. Think about hopping on over there and hooking a brother up. You can also help me by giving me a thumbs up on this video. That adds to my old YouTube juice, and that will get this video shown to more people. Comments help. Subscribe to the channel and share this with other people, because the world needs more people doing engineering and coding and fewer people sitting around watching silly cat videos. Paul McWhorter with TopTechBoy.com. I will talk to you guys later.